Now we can all use a little trig review. So here's just a plain old triangle ABC, and it has to be a right triangle. Note, all right, the trigonometry that we're doing is based in right triangles at this point. So the general idea is that the ratio of sides, when I say a ratio of sides, you guys know I mean to make a fraction of the side lengths. Which side you choose, there's a name for it. So let's just name the appropriate sides. Now it depends on what angle you're talking about. So when I say opposite, I mean opposite of angle, well, if it's C, that means one thing. If I say opposite of angle B, that means another. We never do a trig function from the right angle A because the opposite then becomes the hypotenuse, and we've got a mixed definition there. Now, there's mathematical reasons as well, but let's just say we only do the acute angles when we do trigonometry for this particular process. So let me move forward a little bit. So here we are, sine of C is equal to, now if I give x, y, and z as the side lengths, x over z. Now that's opposite over hypotenuse. Now we'll put up the mnemonic device a little bit later, but that's the idea, is that we have a name for that particular ratio. I mean, we put in x and z as opposite and hypotenuse. Cosine, adjacent over hypotenuse, so that would be y over z. And then tangent from C is the opposite over the adjacent. Now what's cool about that is those ratios, for whatever angle you put in for C, the ratio x over z is actually a known thing. They actually have it calculated for every single angle you could come up with for C. So it could be 10 degrees, 5 degrees, 1 degree, 1.3 degrees, all those, we know the ratio, what x over, if it's sine of 1.3 degrees, we know what x over z should be. And that's what allows us to solve for, if we have one of those values, well then we can solve for the other because we actually know what the ratio should be. And it's done by somebody actually measuring the lengths of the opposite and hypotenuse and so on. So it depends on the angle. So sine of C and cosine of C and tangent of C have those ratios. Well, from the B perspective, sine of B is different. It's y over z because the y is the opposite at B as opposed to what it was for C. Cosine, the adjacent for B, is x. And we have now cosine of B, that's a y, I'm sorry, my handwriting is got, but can you see that from cosine of B adjacent should be x. It kind of looks like I wrote a y in there. It's x over z, but kind of see it go with what I'm saying, not necessarily what it looks like in my writing. Tangent of B is opposite over adjacent, so it's y over x, and that's it. That's your basic run of trig ratios for right triangle. Those are the ratios for any triangle for whatever B and C happen to be. A would be the right angle. Now, let's go to some specific examples how we solve. There's two things that happen. We have a missing side, but we know the angles, and we have to go find the missing side, so we use these trig ratios that have known values, and we use those. Or there's a missing angle, and that's when we use inverse sine or inverse cosine or inverse tangent, the inverse functions. So let me go check this out. Sorry to do a little quick review. Back up there. Kind of cool looking, isn't it? All right, let's set up a little basic scenario. The one on the left is a missing side, and I'm solving for x in both cases, if that helps you at all. And I put a question mark in that one because I wanted you to get an idea of, I can set up all the trig functions on the left triangle. The angle's 55 degrees, the lower, or the right-hand corner, lower right. It looks like I have an opposite side of 3 and a hypotenuse of x. That's actually a clue as to what trig function will work, is by what you have. But I'm going to set them all up. Start with tangent, just to break up the order a little bit. Do a cosine, and we'll throw in a sine. Okay, we have all the ratios. There we go. But the one that works is sine because it has, well, x that we want and a number 3 that'll help. And I can solve that. Take a look at what we have. Sine of 55 equals 3 over x. As cosine of 55 was question mark over x. That's two unknowns. Can't do that. And tangent of 55 degrees equals 3 over question mark. Well, in that top tangent, I could solve for the question mark. But my goal is to find x, so the trig ratio is sine of 55 equals 3 over x. That's the one we're going to shoot for. Sine of 55 is a known value. It's a calculated value. It's a number. Well, so we can solve it as an equation. So number equals 3 over x. I can solve for x in that situation. And then in the other is, what if I have the missing angle situation? I'll set up all the trig ratios over there. and then we'll circle the one that is solvable, given what we have. And if you take a look at it, remember all this is from SOHCAHTOA. I've written it two ways up there. So if you're wondering where I got the ratios of what values go where, it's the mnemonic device course is SOHCAHTOA. And there you have it. Cosine of x has x that I want, and it has numbers for the ratio 5/10. These are idyllic situations. This is how we use trig to solve things. So we set up the trig function that has one variable in it. When you're done writing out, you can set them all up, you can write them all if that helps you. But when you're done, you have to be able to solve for one variable, and out of all those, the two circled ones have an x, and that's what we're solving for. So I'll show you in the next page how to go about solving it. So if I do that, the first one is sine of 55 equals 3/x. To solve for x in that, well, let's just make sine of 55 a number. Equals 3/x. And then I'm going to multiply both sides by x. Now there's a quicker route to this, and then I'm going to divide to get x by itself. Notice that the sine of 55, 0.81292, and the x swapped places in this whole solving process. If you can pick up on that, that's actually a big hint and a quick way to solve those at a higher rate. Okay, so we have x is 3.66 from doing 3 divided by the sine of 55, 0.8192. Now the other one was cosine of x equals 5/10. Well, when we want the x degree, different from the last one where x was on the side and I could just multiply and do some solving to get at that. This one is x is embedded in the trig function. So to get rid of that trig function, you do the inverse trig, cosine -1. That cancels the trig function cosine, leaves x by itself. We have to do it to both sides, so I take the inverse cosine of 5/10, also 1/2. It's a calculator issue. You have to have a scientific calculator to tackle these, or graphing calculator. And inverse cosine of 5/10 equals 60 degrees. Now I say you have to have a calculator, but actually you don't. If you look at this carefully, isn't that 60 a familiar sight? Take a look back on the previous page. Let me show you. Hey, look at that angle. X degrees. I've got a 5 and I've got a 10. What kind of triangle has a leg that's 5 and a hypotenuse that's 10? That means twice as big as 5. Hey, that's a 30, 60, 90, and that would be the 60-degree angle. That's what x ended up being. So we just used trig to find that x is in fact 60 degrees in that situation. So there you have it. Trig functions. It all starts with the ratios, and then if I give you numbers for each of those, b and x and y and z, whatever the angles are or whatever the sides are, you can solve for any missing element depending on what's missing. So if you fill in the angles and you fill in the sides, you can solve when there's one variable present. You use, if you know the angle, you'll be solving for some side. So you multiply both sides by the denominator and solve. If you're solving for an angle, you're going to have to do some inverse trig business. And that's what we have on the right-hand side here. And you can solve for that angle. So that's the big moral of the story. Now let's take this to the next level. I'll take you through some review problems a little bit later, but that's just the general on trig. So try and keep this all in mind. There's the basic trig ratios. There's setting them all up and finding the ones that you can solve. Solving involves, multiplying both sides by a denominator, because sine of 55 is an actual number. And one is when you're missing an angle, you have to use inverse trig to find that actual angle. And you have to do inverse trig of both sides, and it's all about the calculator in that case. All right, email with questions.